Catherine just to slide her foot and just move her vertex to somewhere else that's also interesting. Who is the person that needs to move on this team, and where do they move to? This experience of these people moving, and then the reflected shape also having to move, and of course there's a notation. We go A, B, C, D, and then be A dash, B dash, C dash, D dash. So getting kids exposed to the notation. I move the line of reflection to here. Again, you've got these kids actually holding the OT. If you're still the original shape, I've moved this, slid this, translated it one square, and this square do you move?
Oh, yeah. There's still one away from here.
Yes. So when the line of reflection moves, one of the shapes will move double. So that's a generalisation. Is it always going to be, double if I was moving it to sort of half? When I've been in a more open space, I've also done things like this. I've put the line of reflection, at an angle like that, and then suddenly it really exposes even adults' sense of what reflection is.
Wow.
And it suddenly becomes just a lot more challenging. Can you make a rectangle that has an area of 12 square units?
Show me. Oh, look at that dynamic.
Half of a rectangle.
Yeah, just a quick one. So a lot of my students always go, well, how does a parallelogram, how is the area of a parallelogram 8 times b when rectangles are 8 times b? And so with this, it literally shows if you were, sorry, what was your name? I was just going to say, so if you want to step to the side just one over, diagonally, now what we're dealing with is a parallelogram. Do you want to do the same so you're there?
Oops.
I want to make it show. What we're looking at here is a parallelogram. Each of these are shifted over one. It still has the same area squared because we've done.
How can we check that?
And then how could you check that? Exactly right. How could you check that? So it's literally just shape shifted, but by the same amount. And so having them go see it aesthetically helps those kids to sharpen the visual spatial side of things to actually.
And if you keep your right foot right on your vertex there,
Sorry, yeah.
and you can sort of see how this little bit here, with hands on, it's the same as this little bit there.
Yeah. But you see kids in tests always going, oh, does that match up? Or, whatever it is.
You can get a ruler out and do it, or you could have a mini grid on your big grid.
Yeah.
Or
But they're the opposite. They're
Those are
as you go
complements.
out there, sorry, yes, that's right, they complement each other.
Yeah, and then this
And
bit
that
plus
shape
this bit, that's
complements
another
that.
hole.
Yeah.
Yeah. And it's an important experience for kids to have exposure to. What number are you standing on? So if you double yourself and then add one more, and then you go up matching the squares. Plus one, yep. And you're on, yep. And then maybe. Now, what I often do is I draw kids' attention to, we go through Mussey's position, across one, down two, across one, down two. How does Eleni know when she's in the right spot? Across one, down two, across one, functions, I mean, I was in year 9 and suddenly it all fell into place, but I wish I'd had this experience back in, you know, year 6 or year 5.
Yeah.
But another thing, if you want to jump on 1.5 for me. Yep, so, yep, so double 1.5 is 3 plus 1 more, and you're part of the straight line. So at this point I'll put another kid on 0.5, and double 0.5 is 1 plus 1 more, and they're part of our straight line. I'll send a kid out to, normally the naughty kid, send them out to, plus 100. And how do they know when to stop? It's when they see that they're part of the straight line. So they've got this really strong visual sort of memory of what a function is all about. And you can do then the same thing with the negatives. If you're minus 100, you're a really bad teacher. I'm going to double the debt that you owe me, and then you've been slightly good, so I'm going to add 1, so you're on, minus 99. I think that's a really important thing. Just go back to, those that were on whole numbers, just go back to the whole number part of it. So just, drop the red tape.
And I'm making the same point, because is it going through your head, what happens when I go back to the classroom and say, can you build a tabletop model of what we just did? Not tell them how to do it, but could you build a tabletop model of it? Yeah?
Yeah, absolutely.
And if you let them draw on the tabletop, so like they
Even better, good point.
1 is 2. So 1 times 2 is 2. So forward 1, 2. Yep. 2 or?
I don't think you're crossing one.
No, I'm not plus 1. And Stacey, you're on 2. What number is bigger by 1?
3.
3. So 2 3s are? So you're on 2 now.
That's 2. 3.
4, 5, 6. And you'll see you're on 3, and bigger by 1 is 4, so 3 4s are 12, so you go for 12 spots. Now, getting to the tricky one. What number are you on? 0. And what's bigger by 2? Yeah, how big by 1, 0?
Oh, doesn't matter.
Yeah, so 0 times 1 is 0, so you stay put. And what number are you on?
Negative 1.
And bigger by 1 is?
0.
So negative 1 times 0. You just stay where you are. Yeah. And Mark, you're on negative.
Why negatives? This thing out of negative 1, right, and then I'll go 2.
Yep, so you go 2.
Yeah, so I'll go
4, 2. Yep.
Bang, so.
Now, if I was here at negative 3, how would I know when I stop? Until I'm level with who? So it brings in the sharp focus that idea of symmetry. And also, if you want to jump on negative 1/2 for me. Yeah, so bigger by 1/2 is, oh sorry, negative 1/2. Yeah. So negative 1/2 is 1/2 times negative 1/2, so you go back a quarter, and so that's actually the turning point. So we can have just run the tape around you all. You have to just have a little bit here. And we've got a parabola, quadratic function, and again we've got this sort of really visual reminder.
Face each other, bigger goes to the left. Follow the grid, face each other, bigger goes to the left.
Or too high.
So those two numbers probably would have had to go all the way to the thousands to work out what
Keep facing the numbers to me, please.
and then so forth. And it all sorts itself out.
But we
And so
could-
they're comparing and ordering and thinking about place value whilst thinking computationally as well. So super good.
We could have done fractions.
Yep.
We could have done decimals.
See ya.